All right. We know a lot right now about right triangles. We know a lot, but we don't know everything. Here's what I'm going to do to you today. Please don't write this in your notes. Here's what I'm going to do to you today. I'm going to say, hey guys, angle A up here is 21 degrees. AC is 15. Can you guys find the hypotenuse AB for me? That's what you're going to have the ability to do before you leave or sign off today. Before I show you how to do it, what's wrong with everything I've shown you so far? Why can't I use Hill-Sass here? What's wrong with Hill-Sass in this problem to find x? Radhika?
There isn't an altitude.
Yeah, I didn't even draw an altitude to the hypotenuse. So it's not even the darn diagram for Hills and Sass, so that's out. I showed you Pythag. What's wrong with Pythagorean theorem here? What's wrong with Pythag here? Why can't I use Pythag? Yeah, go ahead.
32 variables.
I don't have enough information, right? I wouldn't be able to plug in for, I plug in 15, but then B would be nothing, and C would be X, and that's not going to go. And then why can't I, I know this is a silly question, but why can't I use 30, 60, 45, 45? Why can't I use those rules? What's the angle?
21.
Yeah, 21. This isn't a 30, 60, or 45, 45. So everything I've shown you is, I don't want to say garbage because it's not, but it's not useful here. It's not. I can't use it here. I'm stuck. That's what today and basically the rest of next week up until quiz 2 talks about is, all right, it's not Hills and Sass. I can't use Pythag. And it's not one of my special right triangles. So what do I do? So here we go. Before I give away what to do, I need you guys to have the ability to do something. So in question number 1, I need everyone to focus on angle A for me. Angle A. If you were looking at angle A, what segment would be the hypotenuse in this diagram? What segment would be opposite angle A in this diagram? And what segment would be adjacent to angle A in this diagram? All right, that's what I'm going to ask a couple of you right now. So if you're looking at my triangle from angle A, what's the hypotenuse segment, the opposite segment, and the adjacent segment? And I know I already have a couple of them labeled there, but hey. All right, let's start talking here. 18. Oh, and what's my hypotenuse in this diagram?
Line AB.
AB, yep, segment AB. All right, what's the segment opposite angle A now? What's the segment opposite angle A? Name it. 21, here we go, Zach. CB is opposite. And then finally, what is the side adjacent? Now, when I say side adjacent, I know there's 2 sides adjacent to angle A, but one's the hypotenuse already. All right, when I ask for an adjacent side, I'm looking for a leg. I don't need the hypotenuse. So what is the leg adjacent to angle A here? 14, here we go. Ellie, what do you got? What's the leg adjacent to angle A?
AC.
AC, good job, Ellie. All right, so there are my sides. I'd like you guys to do the same thing now, but now go from angle B. What's the hypotenuse opposite and adjacent now for angle B? So go ahead, and I'll just ask one person for all of them here. All right, what are the segments from angle B now? Now everyone should be at angle B. All right, give them all to me here. Here we go, 2, 4. Emily, here you go, Emily. What's the hypotenuse in the diagram?
EA.
Still AB. That's not going to change no matter what angle I'm at. All right, what's opposite angle B now, Emily?
AC.
Good job. And what's adjacent to B?
CB.
CB, good. All right, everyone good. Again, when I ask for adjacent, I'm talking about one of the legs. The hypotenuse is never adjacent. It's always the hypotenuse. All right, why do I need you guys to have the ability to find hypotenuse opposite and adjacent? Because I am now going to introduce to you guys three new ratios. And if you remember from last unit, when I talk about ratios, comparing 2 quantities. And I'm going to compare 2 sides of a right triangle with you now. So here they are, brand new. Please stop me if you have questions. Please feel comfortable to stop me. if you have questions, because this is going to be brand spanking new. Let me introduce you to the three ratios we're going to use now in a right triangle. The first ratio is called the sine, and written out it's S-I-N-E, but we abbreviate it S-I-N. It's called sine, not sin. Get out of here. Don't be in that embarrassing math student who calls it sin. Sine, sine. And I know you guys see this new little symbol there. That's called theta. All right, that's called theta. It's a Greek symbol. Please don't freak out. Please don't freak out about it. It's a variable. Okay, so I could have put sine of A, like angle A, sine of B, angle B, but I put theta there, all right? That's an angle measure. Here's what the sine ratio is equal to. It's the opposite side over the hypotenuse side. Okay, that's where I get the two numbers for in the sine ratio. You take the opposite side and put it over the hypotenuse side. That's sine ratio. The second one is called cosine ratio. Cosine, but I abbreviate it COS, so I don't have to write out the whole thing. The cosine ratio, I take the adjacent side and put it over the hypotenuse side. That's where that ratio comes from. I take whatever side's adjacent and I put it over the hypotenuse. And then finally, the third and final ratio is called the tangent. Tangent ratio. I abbreviate it TAN, as you can see. How do I find the tangent ratio? I take the opposite side and put it over the adjacent side. So these are three ratios that we're going to use that are going to find missing sides. Go ahead, questions.
I know with the two angles that we picked, they were both one of the sides forming the angle was the hypotenuse, but let's say you took angle C.
We're never going from the right angle, and I'm going to explain that as we move on. Okay, we go from one of the other two. We're never going to go from the right angle. Gideon, what? What do you got?
I don't know if I'm the only one, but I did SOHCAHTOA last year.
I don't know. Is that something you've done last year? Anybody else? Usually this should be brand new every year when I teach this, but
I did this in engineering this year, but yeah, we didn't do it that extensively.
Okay. All right. Fine. That's fine. If you've been exposed to it, even better. All right. So these three ratios, your head's probably spinning right now. I get it. You're not too sure how we're going to use it. And on top of that, how the heck are you going to remember this? Right? How are you going to remember cosine is adjacent over hypotenuse? Make your index cards, go to Quizlet, right? You do all that great stuff. I got a little device that may help you remember what order all these go in. Anybody familiar with the movie Pocahontas? Let's start there. Familiar with the movie Pocahontas? Seen it maybe? Disney movie? Did you know that Pocahontas had a brother? Anybody know that? Pocahontas had a brother? The brother's name was SOHCAHTOA. SOHCAHTOA. And conveniently, his name can help you remember these three ratios. Take a look. Here's how you spell his name. SOHCAHTOA. Pocahontas' brother. How does his name help you remember these ratios? Watch. The S stands for sine. What's sine equal to? What do you think the O stands for? Opposite over hypotenuse. Sine equals opposite over hypotenuse. What do you think the C stands for? The cosine ratio is equal to adjacent over hypotenuse. And then finally, TOA, tangent, is equal to opposite over adjacent. All right, so hopefully SOHCAHTOA will help you remember the ratios. What's up, Hannah?
I'm pretty sure I learned this last year. We did this weird thing with someone's aunt and a cat. I don't remember it, but I'm pretty sure
I don't know.
I don't either.
Okay. I don't know. Usually it's new for kids every year. So again, it's even better if you guys have familiarity with it. But all right, let's start using this bad boy. Let's stop talking about it and start using it. So look at your bottom right-hand corner box. The box in the bottom right-hand corner. It says find sine of A. Find the sine ratio for angle A. So all our focus right now is going to be on angle A. And if I'm asking for the sine ratio, I'm looking for the opposite side over the hypotenuse. All right? I know I did this one out for you. We're going to do a couple more here in a second. So sine ratio, opposite side over hypotenuse from angle A. So if you guys look at angle A right now, what's opposite A? What's the side length opposite A? It's 13. Over, what's the hypotenuse in this diagram? 22. So the sine ratio is 13 over 22. All right, enough of this. Let's go right underneath. Ready? Write it down. Cosine of A. What would the cosine ratio be for angle A now? The cosine ratio for angle A. All right, first I got to know, you either using SOHCAHTOA or looking up above. What's cosine equal to? What two sides give you the cosine ratio? 2, 1. Here we go. Zach, cosine ratio is equal to what?
18 over 22.
Okay, adjacent, which is 18, over hypotenuse, 22. Good job. Adjacent over hypotenuse. All right, one more. Somebody find me the tangent ratio, but go from B now. The tangent of angle B. The tangent ratio for angle B now. SOHCAHTOA. TOA. Now you're going from angle B. TOA. Here we go, going up top. Omni, what do you have here? The tangent ratio for B.
18 over 13.
Good. Ready? This is how she got it. Opposite side. Here you go. O over A. That's tangent. And then Omni went from angle B and she said opposite is 18. Adjacent is 13. 18 over 13 would be the tangent ratio for B. All right? Questions on how to find those ratios right now before we actually find a side length using them. All right, let me go back to Sophia's point. We will never go from the right angle. I will never ask you for sine, cosine, or tangent from the right angle, and here's why. If I say adjacent, what are you going to do? What's adjacent to the right angle? Which side are you going to pick? That's why we don't do it. Okay? That's why we will never ask you for sine, cosine, or tangent from the right angle. It's always from the other two angles. Any questions from you guys? All right, let's actually solve some problems now. Woo! So here we go. Example 1. Solve for x, nearest tenth. Pythag isn't working. 30, 60, 45, 45 isn't working. Hills and Sass, but I always can do some SOHCAHTOA. First thing, I go from the given angle, the acute angle, the angle less than 90. So everyone focus on angle B, 36. I need your help. Can you identify what side X and what side 15 is? Opposite, adjacent, hypotenuse. Can you help me? Yeah, you can. 22. Here we go, Hannah. What's X in that diagram? X is the hypotenuse. You don't have to. What I like to do is, oh, that's the hypotenuse. I remind myself by just putting a little h next to it in parentheses. That just reminds me you have the hypotenuse, Carlino. And what's the 15 now? Here you go, 14. Ellie, what's the 15? Is that opposite or adjacent to my 36?
It's opposite.
It is. So again, I'm going to put a little O that reminds me I have the opposite side. All right, now the wheels start turning upstairs. Now you're saying to yourself, I have the opposite side and I have the hypotenuse. What ratio could I use then? What ratio out of the 3 uses opposite and hypotenuse? That's what I got to start thinking right now. You are allowed to use what ratio now? Okay, 3, here we go. Omni, go back. What ratio uses opposite and hypotenuse?
Cosine?
Ooh, look back. Opposite and hypotenuse. Cosine uses adjacent.
No, sine, just
Sine, good. And again, we abbreviate sine, S-I-N. So I'm going to use the sine ratio. Now I don't want to put in angle B. I actually know what it is. So I don't want to put a B here. I'm going to put 36. I already know what it is. So the sine of 36 is equal to, here you go, what's the ratio now? The sine of 36 is equal to opposite, I already labeled it, 15 over hypotenuse, x. So I picked the sine ratio because I had opposite and hypotenuse. I put in 36 degrees, I knew the measure. That ratio is equal to opposite over hypotenuse. Ooh, how do I solve it now? Is the question. How do I solve this for x? Here's my suggestion. Does this help? Remember, sine of 36, even though it's not showing, it's over 1. I think we solved a bunch of these last unit, didn't we? This is a proportion. Anybody at home, how do I solve a proportion around these days? Solve a proportion?
cross multiply.
Cross multiply. Let's do it. Let's do it. Ready? I'll go this way first here, I guess. Sine of 36 times x. I'm just going to write it down. Sine of 36 times x equals 15. Let your algebra skills take over. I got to get x by itself. X by itself. Even if you're wrong, who cares? You were brave enough to guess. Anybody know what I need to do on both sides here if I'm going to get x by itself? What's up, Hannah? Go ahead. Divide everything by sine 36. To get the x all by itself, I'm going to divide both sides by the sine of 36. All right, now let's talk calculator. Please just don't go crazy on me here. Sine of 36 is a number. I point something, I don't know what it is as a number, but it's a number. Go to your calculator, everybody, please. I need you to do something first. Go to your mode button, please. Hit your mode button. There are two ways to measure an angle. Two ways. One is degrees, which you're familiar with your whole entire life, and the other one's right next to it, which is called radians, which we'll deal with later on in the year. Please make sure your calculator is in degree mode, because we'll be just dealing with degrees. There's no reason for it to be in radians. Make sure it's in degree mode. Okay? So now let's finish the problem. We're trying to figure out 15 divided by sine of 36. I always put it in a fraction template, but you don't have to. So 15 over, everyone see your buttons now? The new ones we're going to use? Sine, cosine, tangent, right in the middle of your calculator. There are your 3 new buttons we're going to use. So I want to use sine, 36? Of 36. And your calculator has it already programmed in what that number is. And there it is. There's my side length. Again, if you are not getting this 25.519, put your calculator in degree mode if you miss my explanation. All right, be ready to round a lot now, this second part of the unit. Be ready to round a lot. It says nearest tenth, so I'm going 25.5 centimeters. Okay, so this is the new way. Now that I can't use pi fag or 30, 60, 45, 45, here's another method of finding a side length.
Quick question.
I'm ready. Let's go.
Why couldn't you have set this as cross multiplication of? I wrote it down at first as like 36x equals 15.
But it's the 30. Watch. Ready? 36. Here's the number 36. Here's sine of 36. That's that number. Two totally different things we're talking about. Okay, that's why I got to put sine of 36, because we are talking about an, obviously, you guys can see right on my screen right now, different number. Okay, different number. All right, 1 does not make us great. Let's keep trucking. On number 2. Find side x. Again, we don't go from the right angle. You always go from whatever acute angle that's given. All right, can you guys help me find what side x and what side 37 here? Opposite, adjacent, hypotenuse. Help me out. What are those two sides going to be labeled as? 10, here we go. Atticus, what's the 37 going to get labeled as?
Hypotenuse.
Yep, and how about the x here?
Adjacent.
That's the adjacent side, the 48. Good job. So I have adjacent, hypotenuse. You guys got to figure out what ratio can be used then. SOHCAHTOA. If I have A and H, which ratio can be used here? Here you go, 2, 5. Sabrina, which ratio here? Cosine. Good job. And we abbreviate cosine with COS. So I'm going to use the cosine ratio. Cosine, not a V, but a 48 degrees. I already know the measurement. So the cosine of 48 will be in what ratio here? Cosine of 48 is equal to, put the sides in the right order for me. 8, here we go. Ryan, put those sides in the right order.
X over 37.
Good. Adjacent side over the hypotenuse. Perfect. There you go. So we just built, sorry guys, we just built our equation there. All right, put it over 1 if it makes you happy. You don't need to though, but put it over 1. And let's cross multiply. Oh, look what happens here. X equals cosine of 48 times 37. You guys see there's no reason to divide. Sometimes we may have to divide. Here we don't. We don't have to divide here. We just now go to the calculator. Cosine 48. Please close your parenthesis. Times 37. Look at the rounding directions. Nearest inch. So I got to round to the nearest whole number, 25 inches. Questions from you guys? So yeah, sometimes you're going to have to divide in the problem. Sometimes you won't. Depends what type of setup you have. Any questions here on the basics? Because now what I did, just so you know, I picked old Regents questions that dealt with sine, cosine, tangent. So what you're about to see and do have come off old Regents exams. So number 1 here. Classic problem, ladder leaning against the wall. Determine and state the length of the ladder. All right, well, if the ladder's leaning against the wall, this is going to have to be the ladder, I presume. All right, we all see the acute angle that I'm going to go from, 75 degrees. So let me turn it over to you guys. What's the 15 and what's the x now? What sides am I given here? Oh, here we go, 9. Audrey, what sides am I given here? How about let's start with the 15, Audrey.
What's the opposite?
Great job. And how about the side I'm trying to find? X.
It's the hypotenuse.
Great job. Good work. So I'm given opposite and the hypotenuse. So this would allow me to use what ratio in the equation now? 18. Oh, and what ratio can I use with opposite and hypotenuse?
Sine.
Sine. Good job. So here we go. Sine 75. That ratio is going to be, going back, Emily, sine of 75 should be equal to what?
15 over X.
Good job. Opposite side, 15 over the hypotenuse, x. There you go, guys. 70, put that over 1 if you feel like it. Here we go, cross multiply. The sine of 75 times x equals 15. And then, yeah, here we go. This is a one where we do have to divide both sides, not by 75, sine 75, all of it. I prefer you use a fraction to alpha y equals on your calculator and plug it in, but you can use the division sign. And we're rounding to the nearest tenth, it looks like, nearest tenth. No, you guys, yeah, nearest tenth, sorry. So nearest tenth, what do we end up with here? Nearest tenth. 17, here we go. Maeve, what'd you end up with? Nearest tenth.
I haven't gotten it yet.
Okay, when you do, let me know. Take your time.
I got 15.5.
Got it. Good job. 15.5 feet. All right. Guys have any questions there? All right, I think it's time for you guys to try one out on your own now. So here we go. Nearest foot, what's the value of x? Try one out on your own. Label your sides. Remember, you're going from 40 degrees here, the acute angle. Label your sides. Figure out what ratio to use, then write the equation. And this is not a one-day thing, all right? Hopefully we're using the cosine ratio here. Take your time. I'm ending up with 18 feet, rounded to the nearest foot, 18 feet. Take your time. Cosine ratio, adjacent over hypotenuse, cross multiply, and then divide both sides by the cosine of 40. Anybody Any issues there you want to talk about at home? Anything here we got to talk about? I think we'll have time for one more problem, it looks like. Anybody in here have any issues? And I know we're not going to get to all of them, which is fine. Again, this is not a one-day topic. We're going to be doing this all next week, too. This is what your quiz is on next week. All right, last one here. A little bit different. I actually don't need to find a side length. Let's see. Yep, triangle ADE, BC, parallel to DE. Wonder why they gave me that, but hey, we'll talk. What ratio is always equivalent to the sine of angle A? All right, so sine. Somebody tell me, what's the sine ratio equal to as far as opposite, adjacent, hypotenuse? Let's start there. 16, here we go. Kyla, what's the sine ratio equal to?
Opposite over hypotenuse.
Good, perfect. Opposite over hypotenuse. And this is the first time I'm going to bring this up today. Sine, cosine, tangent can only be used in a right triangle. That's our topic this unit, right triangle. All right, I cannot use sine, cosine, tangent on any old triangle. It's got to be a right triangle. So right now, the only right triangle I see up here is the big dog, ADE. That's a right triangle, so I can use sine on that right triangle. We're going from angle A. From angle A. Ooh, again, Emily, here you go, Emily. What is opposite angle A in triangle ADE?
DE.
DE, good. And then Emily, stay with me. What's the hypotenuse in that triangle?
AD.
All right, DE over AD. Oh, boy. Uh-oh. That's not a choice, guys. It's correct. It is correct, but it's not a choice. Yikes. Okay, so what the heck then? What the heck? Is there another right triangle in this diagram? Hannah, is there?
Yeah.
Where?
ABC.
You better prove to me why angle BCA is a right angle then. Perfect. I love it. Parallel lines mean these two angles here are corresponding, so they're congruent. Perfect. So not only is there one right triangle, I got a second right triangle now. So let's finish this strong. Here we go, Will. Now, Will, in my new right triangle, ABC, what is opposite angle A?
Side BC.
BC, and what's the hypotenuse in that triangle ABC?
Side AB.
All right, so another way to do sine of A, I could take BC over AB, which is a choice here. Perfect. Good, good. All right, so again, this can only happen if I give you a right triangle, which I always will, but any questions? Because that's, I'm not going to try to fit in the next problem. Any questions there from you guys? Okay, guys, you can't slack on the homework because this is brand new stuff. And it's the only way we're going to get better at it. And it's not today, it's also tomorrow and all next week. This is what your quiz is on next week, sine, cosine, tangent. All right, come with all your questions tomorrow. Make sure you show work on the homework. I'll see you guys tomorrow. Whew. I guess I'll see you guys on Monday, huh? Guys, have a good one.